Hello everyone, welcome to lecture 13 in college algebra, and this is going to be on section 4.2 from the textbook, which is on modeling with linear equations. So basically we're going to be looking at applied problems that are going to involve linear functions or linear equations. So let me start off with an example using, actually a couple of examples using tables. So let's say you're told some values of a linear function are provided. They're going to be provided in the table in a second. And based on that, we want to complete the table. Okay, so let's say these values were given. So x is my input, y is my output. Let's say I have 1, 2, 3, 4, 5. And then I have -4, -2. And let's say these are unknown. I'll just do squares here for unknown. So we want to complete the table. We want to fill in those values in those squares there. Okay, so how do we do that? Well, we're told that this should be a linear function, right? So to be linear, the slope must be constant, right? That's going to be the key thing. The slope must be constant, right? It's going to be one particular value. It's not going to change at all. And how do we figure out the slope? Well, we can get that by looking at the first two ordered pairs, right? If I look at the first ordered pair, which is 1, -4, think of it as like my first point, so x1, y1. And the second ordered pair is 2, -2, so this is like x2, y2. I can compute the slope, right? So the slope is going to be y2 minus y1 over x2 minus x1. So it'll be -2 minus, -2 minus a -4 over 2 minus 1. Well, -2 minus -4 is -2 plus 4, right, which is 2. And then 2 minus 1, of course, is 1. So this is just equal to 2. So the slope is 2. And you can see that here, right? As the x value increases by 1, the y value increases by 2. It goes from -4 to -2. So it's an increase of 2. So again, if I go to the second one, we could, figure out what this value is by figuring out the slope, but it's easier to just look at the table here. If this is increasing by 1, then this has to be increasing by 2 again, right? So if it has to go up by 2, what's -2 plus 2? That's going to be 0. And if I increase by another positive 2, this has got to be 2. And then another 2, this has got to be 4. So those must be the values, right? And they will give you a constant slope of positive 2. Do you guys see that? The other way of saying this is if the input increases by 1, then the output, right? Remember, the input is like the x, the output is the y. The output increases by 2, right? Because the slope has to be the change in the output over change in input. All right, here's another example given a table. Let's say you're given the linear function in the table below. So once you have that, right, once I give that to you, I want you to find the slope, the y-intercept, and a formula defining that linear function. So find the slope the y-intercept, and the formula, or I'll say the equation, the linear equation. Okay, so here's my table. My input, and let's say the function I'll call h, so this is h of x. So -6, -4, -2, 0, 2, 4, 6. And let's say this is 24, 18, 12, 6, 0, -6, -12. Okay, so I want to find the slope first, right? Well, since this is linear, it doesn't matter what 2 points I use to find the slope. Maybe just use the first 2 points. Okay, so let's say I use -6, 24. I'll call that x1, y1, and then maybe -4, 18. But really, I could use any 2 points, right? Because it's linear, so the slope is not going to change. So if I use those 2 points, the slope is going to be y2 minus y1 over x2 minus x1. So this is going to be a -6 over -4 minus -6 is -4 plus 6, which is +2. So I guess this is going to be a -3. Okay, what else do we have to find here? The y-intercept. Well, actually, that's easy, right? Because remember, the y-intercept is the point 0, comma b, where b... Well, typically people call b the y-intercept, but really 0, comma b is the y-intercept. But we can read that directly from the table, right? If I look at the table here, I have this point 0, comma 6, right? Remember that 0, comma b. So that is the y-intercept. So the y-intercept is the point 0, comma 6. And we know that in this case that b, if we really want b by itself, b is equal to 6. Okay, and then finally find the equation of the line. Well, that's easy. We can use the slope-intercept form. So y equals mx plus b. Because we know the slope, that was -3, and we know b is 6. So that must be the equation of the line that represents that particular table. Okay, so we can ask different questions involving tables. The other thing that's important is sort of what I like to call applied problems, or you guys may have heard them as word problems. So let's look at some word problems now that are going to involve linear functions. Okay, so here's an example. You're told a town's population has been growing linearly, right? So we know we can model this using a linear equation. In 2003, the population was 65,000, so 65,000 people. The population has been growing by 700 people per year, and we want to write an equation for the population P X years after 2003. And then once we have that, we can use that to answer the question, what is the population in 2009? Okay, so we know it's a linear equation, so it's going to have the form, right, y equals mx plus b. But the output y is really the population, which we want to call p. So we really want p is equal to m, and x is going to be the years after 2003. So that is our input plus b. So you can think of this as the population p is a function of x, right? It depends on x, depends on years, the number of years since 2003. Okay, so we need to figure out m, we need to figure out b, right? Well, remember m is the slope, but it's also the average rate of change. So in this case, the m is given in the question itself, right? we're told that the population has been growing by 700 people per year. So that is the average rate of change. That's the slope. It's 700 people per year. So we have that. Now remember what B is. B is the initial population, right? It's the population when the X variable is 0. So let's think about what X is first. If you look at the problem, we want X to represent the years after 2003, right? Let me make a little table here. Let's say this is the year, and let's say this is X. So if it's 2003, 2004, and so on, I'll go up to 2009 because we're going to need that later. If X represents the years after 2003, then at the year 2003, X is equal to 0, right? At 2004, well, how many years after 2003 is that? That's 1 year after. How am I getting this value? I'm just subtracting the current year I'm in minus 2003, right? So this would be 2. And then if I want what X represents for the year 2009, it'd be 2009 minus 2003, which is going to be 6. Okay? So the B here represents the starting value when the input is equal to 0. So when X is equal to 0. But what is that value? Well, we're told that in the question, right? In the year 2003, that means X equals 0, the population was 65,000. So B is going to be 65,000. So now I'm done. I have my linear equation. I know that the population P is equal to the slope, 700 times X plus B, but B is 65,000. Okay? And now if I want to figure out what is the population in 2009, I want to know the population when X is equal to 6, right? So if I think of this as a function, P of X is equal to 700X plus 65,000, I can just evaluate that population when X is equal to 6. So where I have an X, I'm going to plug in a 6. So, and if you work this out, right, 700 times 6 is 4,200 plus 65,000 is going to be 69,200. And really it has units, right, of people. It's a population. Okay, let's do another problem that's similar. Okay, so in this question, it says, in 1993, the moose population in the park was measured to be 4,570. By 1999, the population was measured again to be 4,750. If the population changes linearly, find the moose population P in terms of T, where T represents the years since 1990. Okay, so first let's make sure we understand what T is again, right? So if the year is 1990 and T represents the year since 1990, T must be 0, right? If it's 1991, then T would be 1, right? And I'm just getting that by subtracting. If it's 1992 minus 1990, T would be 2. 1993, T would be 3, and so on. Okay, if it's 1999, then T would be 9. All right, so it's telling us in 1993, the moose population was 4,570. So when T was 3, right, so in 1993, T is 3, the population is 4,570. Think of this as like T1, P1. And then when T was 9, so in 1999, T is 9, the population was 4,750. So this is like T2, P2. So now, given that, we can calculate the slope, which is the average rate of change, right? So the slope in this case would be P2 minus P1, the change in the population, over the change in time. So this would be 4750 minus 4570 divided by 9 minus 3. And this turns out to be 180 over 6. Right, which you can simplify to 30. Remember, it has units, right? Population is number of moose, so it's moose per, and then T is in years, so it's moose per year. So 30 moose per year, it's increasing by 30 moose per year, right? Because it's positive 30. Okay, so now I can figure out my equation. I guess just for variety, I'll use the point slope form. So remember, that's y minus y1 equals m times x minus x1. Except in this example, we're calling y p for population, and the x is t for time. So really, this is like p minus p1 equals m times t minus t1. Okay, so if I fill in here, I have p minus, well, population 1, I can use either point, but I'll just use the first one. So this is 4570, is m, which is 30, and then t minus t1, but that was just 3. I can distribute the 30, so I have p minus 4570 is 30t minus 90. And then to get p by itself, I'm going to add 4570 to both sides. And if you do that, you're going to get p is equal to 30t plus 4480. And that's it. That's our equation, right? The population, I'll even make it clearer here, is a function of time. Once we have that, we could ask more questions. Like, for example, what if you were asked, what does the model predict? So assuming it's still going to be growing linearly, the moose population, what does the model predict? The moose population to be in 2003. Assuming the growth is linear still. So first of all, we have to figure out what t is, right? But remember, to figure out t, I would just take 2003 and subtract 1990. So that's going to be 13. And then I'm just going to plug it in, right? So really, I'm evaluating the population when t is 13. So it's 30 times 13 plus 4480. And if you work that out, you're going to get 4870. And again, it has units, right, of moose. Okay, so here's another question. It says, Terry is skiing down a steep slope. Terry's elevation, E of t, in feet after t seconds is given by that linear equation. E of t is equal to 3700 minus 70t. Okay, so E of t is equal to 3700 minus 70t. Now, no, it doesn't matter how we write this, so I could write it in the mx plus b form. I could put the negative 70t first plus 3700, right? That's how you're used to seeing it, but it doesn't really matter. And we're asked two questions. What was Terry's initial elevation? And then what was Terry's rate of change of elevation? So really, these questions just depend on knowing the basic idea of a linear equation, right? Remember, the b represents the initial value. It's the value when t is equal to 0. So if we want to figure out the initial elevation, You could just plug in 0, right? You say, what is the elevation when t is 0? Well, that's going to be negative 70 times 0 plus 3,700, but that's just equal to 3,700 feet in this case. Okay, the quick way of getting that would be to recognize that this value, this b, is the starting value. Right, when the input, in this case t, is equal to 0. So we could have just read it off. And then the rate of change of elevation, that's going to be the slope, right? So the rate of change of elevation is the slope. And again, we can read that directly from our equation. That must be the negative 70 feet per second. Right, so it's the slope of that particular linear equation. Okay, let me do one more question. Okay, so in this example, we're told that Marcos purchased a calling card for his prepaid cell phone. His remaining balance B can be modeled by the equation B equals 25 minus 0.1n, where n is the number of minutes he's talked since purchasing the card. And there's 3 questions. How much money was on the card when he purchased it? How many minutes will he have talked when he runs out of money? And then what is the slope of the equation and what are the units? Okay, so again, these questions just refer to the general idea of understanding what a linear equation is, right? So in this case, let me write down the equation right here. I have b, you can think of it as a function of n, right, is equal to 25 minus 0.1 n. Now, if we want to put it in the slope-intercept form, we can just rearrange this. I can put this term, negative 0.1 n first, plus 25. So to answer question A, how much money was on the card when he purchased it? Well, that is the starting value, right? So we could just look at that equation and pick out the b, which is our starting, like little b, which is our starting value. Or the way to think about this, it's the balance when the number of minutes talked is 0, right? He hasn't talked any minutes yet, right? It's starting, so when the number of minutes is 0. So this is going to be 0.1 times 0 plus 25. And of course, we're going to get that value 25, right? Because that is the starting value, right? This has the form y equals mx plus b, so it must be that b there. But it's easy just to plug in 0 to make sure. And it has units, right? It's $25 would be the starting value. Okay, what about question B? How many minutes will he have talked when he runs out of money? Well, what does it mean to run out of money? It means that his balance is going to be equal to 0, right? So if the balance is equal to 0, what are we looking for? We're looking for n. What's the total number of minutes that he talked? Well, I can solve this by setting b equal to 0. So I have 0 is equal to negative 0.1 n plus 25. So let me solve this for n. So I'll subtract 25 from both sides. So I have negative 25 equals negative 0.1 n. Now I need to divide both sides by negative 0.1. So I'm going to get n is equal to, well, what's negative 25 divided by negative 0.1? That's 250, right? Of course, you could write it this way. N equals 250, and that has units of minutes. So if he talks for 250 minutes, his balance will be at 0. And finally, the last question was, what is the slope of that equation and what are the units? Okay, so again, if we look at the equation, let me write it one more time. So b of n is negative 0.1 n plus 25. Then the slope, I can just pick out that slope. This is the slope value right here. All right, so the slope is negative 0.1. And the units are dollars per minute, right? So every minute he talks, it's decreasing by $0.1, by 10 cents. His balance is decreasing by 10 cents. So these units are dollars per minute. And since it's negative, we know that it's decreasing, right? His balance is decreasing. All right, so that's it for 4.2. The next section, actually, we're going to jump all the way over to chapter 11. We want to do one section from chapter 11, which is going to look at systems of linear equations. So, and basically, we'll look at systems of two linear equations. All right, thanks.